Welcome to educator.com. In this lesson, you will be learning to solve equations by multiplying. You're going to be solving equations by multiplying fractions. Applications of this are to determine amounts of material needed for a project or to predict changes in water level. Vocabulary for this lesson is the multiplicative inverse. That's also known as the reciprocal of a number. It's used to isolate the variable. For example, the multiplicative inverse of 1 over 3 is 3 over 1. Because when I multiply these numbers, 3 and 3, it will help me to isolate the variable, because then by multiplying by 1, any number multiplied by 1 will give me the same value back. Let's try solving an equation and we'll use the multiplicative inverse. 5d equals 7 12 over 10. First off, I would simplify the 12 over 10. 5d equals 7 and 6 over 5. And the 6 over 5 can be simplified to give us a remainder of a new 1 whole with the remainder. So this 1 will become, with the 7, will be 8 and 1/5. Now, to multiply fractions, you need to change any mixed numbers into improper fractions. 8 times 5 is 40, plus 1 is 41. So 5d equals 41 over 5. Now, let's get rid of this 5. The multiplicative inverse of 5 is 1 over 5. You could see this by changing 5 into a fraction. Put it over a 1. The reciprocal, or the multiplicative inverse, is 1 over 5, basically flipping it upside down. Here, the 5 and the 5 cancel, and the 1 and the 1 cancel, and you've isolated your variable. D is alone. 41 times 1 is 41, and 5 times 5 is 25. If you want to change that into a mixed number, 25 goes into 41 once, and you're left with 11 minus 5 is 6, and 3 minus 2 is 1. So D equals 1 and 16 over 25. So remember to change, simplify if possible, so that you can work with smaller numbers. Remember to change any mixed number into an improper fraction, and then use the multiplicative inverse. Let's try another example. 4 over 5 times x equals 9. So I'm going to take the multiplicative inverse of 4 over 5, which is 5 over 4. And over here, I'm going to take this 9 and change it to a fraction so that I can multiply with a fraction, 5 over 4. Notice the property of equality tells me that the multiplication property of equality tells me I'm going to be multiplying the same number to both sides. The 5 and the 5 will cancel, the 4 and the 4 will cancel, so I've isolated my variable, x is alone. 9 times 5 is 45, and 1 times 4 is 4. Let's change that into a mixed number. 4 will go in one time, leaving me with a 0. Bring down the 5, and it'll go in once again, leaving me with 1. So x equals 11 and 1/4. Let's try writing the multiplication equation. Sean was refilling his pool after a hot day. The level of the water rose 10.5 inches in 8 3/4 minutes. How many inches per minute did the water level rise? So he's filling his pool, maybe with the hose, and the water level is going up. And he wants to find out how much each minute the water level is rising. Maybe he wants to leave the hose there for a while and walk away. So let's take 10.5 inches, and we'll divide by the 8 3/4. We're finding a unit rate here. So first I'm going to change the 10.5 into a improper fraction. 10 times 2 is 20, plus 1 is 21. 8 times 4 is 32, plus 3 is 35. Now, to divide fractions, you need to take the reciprocal of the second. So 21 over 2 times 4 over 35. And once you've taken the reciprocal, the division becomes a multiplication. I can cross-simplify here. I could divide both by 7, and that'll really help me out because I can work with smaller numbers. And then diagonally here as well, I could divide by 2 and get 1 and 2. So 3 times 2 is 6, and 1 times 5 is 5. And to simplify that, 5 will go into 6 once, with the remainder of 1. So now I'm going to have 1 and 1/5. So the water is rising at 1 1/5 inches per minute. Let's try an example with multiplying fractions. 7/8t equals -42. The multiplicative inverse of 7/8 is 8/7. And according to multiplication property of equality, I'm going to multiply both sides by 8/7. These will cancel and these will cancel. And I've isolated the variable t. And on this side, on the right side, I'm going to change the -42 into a fraction by putting it over a 1. -42 times 8, I'll have to multiply it on the side here, 16. 4 times 8 is 32, plus 1 is 33. So I have -336 over 1 times 7 is 7. And I'm going to simplify that by changing it into a mixed number. 7 will go into 33 4 times, which is 28. And it'll go into 56 8 times. So I get a perfect -48. So t equals -48. 3s equals -4/9. So the opposite of multiplying by 3 is to divide by 3. So I could say divide by 3, divide by 3. 3 divided by 3 simplifies to 1, and 1 times s is s, so I've isolated the s. Now to divide these two numbers, I'm going to change the 3 into a fraction by putting it over a 1. And when you divide fractions, you need to take the reciprocal of the second one. So that's going to make it 1/3. Once you've taken the reciprocal, your division can change into a multiplication. So s equals -4, and 9 times 3 is 27. So -4/27. Remember that with negative fractions, this would also equal -4/27, which also equals 4/-27, as long as you only have one negative in your answer. Let's try an example with a word problem. A student has $12.75 in her piggy bank. This is 2.5 times as much as her sister has in her bank account. How much money does her sister have? So if you take 2.5 and multiply this with her sister's amount, this will equal what the student has, $12.75. Remember to set the variable equal to what you don't know, so we'll call that s. First, let's change this fraction into an improper. 2 times 2 is 4, plus 1 is 5. So 5/2s equals 12.75. I'm going to take the 12.75 and change that into a fraction. So now this 0.75, put it over 100, and you could simplify that to 3/4. So I have 5/2s equals 12 and 3/4. Now I'm going to take this mixed number and change it into an improper. So 5/2s equals 12 times 4 is 48, plus 3 gives me 51/4. To isolate s, I'm going to multiply both sides by the multiplicative inverse, which is 2/5. This cancels, and I have s alone. I've isolated s. I can cross-simplify here to make my numbers easier to work with. I'll have 2 and 1. Then I'll have 51/10. And if I simplify that, I'll have 51. 10 goes in 5 times, leaving me with 1. So I'll have 5 and 1/10. Now remember that the word problem is asking you for how much money the sister has. So let's change 5 and 1/10 into a dollar amount. So the sister has $5, and 1/10 of a dollar is 10 cents. The sister has $5.10. Let's go back to our word problem. The student should have 2.5 times as much as the sister. If the sister has $5.10, the student does indeed have 2.5 times more. 9.5 equals y minus 4/9. So in this case, the opposite of subtracting 4/9, or the inverse, is going to be to add 4/9. 4 over 9 minus 4 over 9 becomes 0. In the case of adding fractions, you do not need to change your mixed number into an improper. You just need to make the denominators the same. In this case, they can both be 18. I would multiply by 9, and I would multiply by 2. So here 9 is 9 and 9 over 18, and I'm going to be adding 8 over 18. 9 and 8 makes 17 over 18, and 9 plus 0 is 9. And let's write it in the conventional algebraic form, which is y equals 9 over 17 over 18. Y equals 9, 17 over 18. So in this example, we are not multiplying by a fraction, but in fact, we're going to take the inverse operation of subtracting, which would be adding. So make sure that when you're working with the fractions, you're always checking for the inverse operation. The inverse of adding is subtracting, and the inverse of multiplying is dividing, or using the reciprocal, the multiplicative inverse.